In the previous lesson, we looked at what it took for any polygon to be similar, and that was that corresponding sides had to be congruent and corresponding sides had to be proportional. So now we're going to look specifically at triangles and look for shortcuts instead of having to show all three pair of angles are congruent and all three pair of sides are proportional. Kind of like what we did with congruency. There are shortcuts. There are not 5 shortcuts, there are only 3, so that should be less for you to memorize. And the first one is going to be angle, angle. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are going to be similar. So if you're looking at this picture, because angle A and angle F are congruent, and because angle B and angle G are congruent, then triangle ABC is similar to triangle FGH by the angle-angle similarity. Side, side, side is another way to prove that triangles are similar. If all your corresponding side lengths are proportional, then the 2 triangles will be similar. So if you set a proportion up between JK and MP, JL and MQ, and LK and QP, if those all give you, if they're all proportional to one another, then you know the 2 triangles are similar by side, side, side. Our third way to prove that 2 triangles are similar is using side, angle, side. If the lengths of 2 sides are proportional and the included angles, it's got to be the angle in between the 2 sides, are congruent, then the triangles are going to be similar. So you know that RS over XY is proportional to ST over YZ, and you know angle S and angle Y are congruent, then you know that triangle RST is similar to triangle XYZ because of side, angle, side. So we're just going to look at some problems deciding whether or not they are similar by one of these 3 reasons. If so, which reason? We'll write a similarity statement, and if not, we'll explain why. So in this picture, we have 2 triangles. We can see that all 3 sides are given. You can't jump to the conclusion side, side, side. You have to make sure that they are proportional. So we're going to check for proportionality. So I'm going to start with the triangle on the left. My shortest side is 6. The triangle on the right, the shortest side is 4. Triangle on the left, the medium length side is 8, and the triangle on the right is 5. And finally, on the triangle on the left, the longest side is 12, and the triangle on the right is 8. So you can either try to simplify them and leave them as fractions, or you can change them to decimals. It's really up to you. 6 over 4 does simplify to 3 over 2. 8 over 5 does not simplify, and 12 over 8, if you divide both of those by 4, simplifies to 3 over 2. So if I'm comparing these 3 fractions, these 3 fractions are not the same, so these are not similar. If you change them to decimals, which is a possibility, 3 over 2 is 1.5. 8 over 5 is 1.6. And so since those are not the same, then these are not similar. No, and you could say sides are not proportional. So 2 of the 3 sides are proportional, but not all 3 sides, and it's got to be all 3 sides. So this is not side, 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 even though it might appear that way at first glance. Okay, in this picture, notice that we do have those little pink arrows, which means the lines are parallel. And hopefully after the last couple units that we've done, especially Unit 2B, when you see parallel lines, you should know that there are some angles that are congruent, so we need to identify those angles. Because the lines are parallel, angle J is going to be congruent with QPL because they're corresponding angles, and angle K is congruent to angle PQL also because they're corresponding angles. So since we have two pair of angles, then these triangles are similar by angle. It didn't work for congruence, but it does work for similarity. And if I'm going to say a congruent statement, triangle PQL is similar to triangle JKL. Remember that the order is really important when writing a congruent statement. There is more than one way to write it, but there are definitely correct ways and incorrect ways. So you need to be really careful to make sure that you get those right. And remember that if you know two angles are congruent, then you do know the third angle is congruent by the third angles theorem. And those would also be congruent even without the third angles theorem because L is actually in both triangles, so that is a reflexive angle. All right, on these two triangles, we kind of have that hourglass shape. Remember that you always have vertical angles that you can mark, although you don't need to mark them for this one. We do have all three sides, so it is possible that these are similar because of side, 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 but we do need to check for proportionality. So I'm going to take my top triangle and I'm going to do my shortest side in the top triangle, which is 5, to the shortest side in the bottom triangle, which is 12.5. Then I'm going to go to medium in my top triangle is 6, medium in the bottom triangle is 15, and then longest in the top triangle is 8, longest in the bottom triangle is 20. So we can simplify all of these fractions and see if they're the same. The fact that you have 5 over 12.5 might throw you off a little bit. It may be more difficult for you to simplify it with a decimal in it. So if you want to, you can just change these all to decimals. 5 divided by 12.5 is 0.4. 6 divided by 15 is also 0.4. And 8 divided by 20 is also 0.4. So since all three sides are proportional, these are similar by side, side, side. If you choose to use vertical angles, you could actually use side angle side, but we don't really need those vertical angles because we had enough with what was given to us, but it is something you could add into the picture. And so then we're going to do our similarity statement, and we've got triangle PQR is similar, and be really careful when you do PQR. P falls between the medium and long leg, which in the other triangle is S, then T, and then R. Okay, on this one, are the triangles similar? We have no sides marked at all, but we do have angles. We have a right angle in both of them, and then we have 44 in one triangle and 47 in the other. So what I would suggest doing is in triangle ABC, find the missing angle A. You can do that by doing 180 minus 90, because there's a right angle in there, and then minus 44, and that's going to give you 48 degrees. The fact that that's 48 degrees and not 47 should tell you that these are not going to be congruent. The angles are not going to be congruent, so the triangles are not similar. So no, and your reason would be angles are not congruent. You do not even need to find angle G, but you can by doing 180 minus 90 minus 47, and you're going to get 43 degrees. So clearly those angles are completely different, so these are not going to be similar. All right, in our next one, we have two sides and the included angle. So if anything, this is going to be side angle side because those included angles are congruent. However, we need to make sure that those sides are proportional. So I'm going to take my shortest side, which is 18 in triangle AJK, and then I'm going to take my shortest side in triangle SWY, which is 12. And then I'm going to take my my longest side in AJK, which is 24, and divide by the longest side in triangle SWY. So there are a couple different things you can do with this. You can simplify these fractions. So 18 over 12, each is divisible by 6. 18 divided by 6 is 3. 12 divided by 6 is 2. For 24 and 16, you can divide both by 8, which is going to be 3 over 2. So you get the same fraction, those equal each other, so it's proportional. You could also change 18 over 12 into a decimal, which would be 1.5. You could change 24 over 16 into a decimal, which would be 1.5. Those are the same, so that means it's proportional. Or the other thing you could do is you could cross multiply. And if you cross multiply, let's see what we get. 18 times 16 is 288. And then 12 times 24 is also 288. So you have, after you set the proportion up, you have kind of 3 different ways to verify that it is correct. Reducing, turning to decimal, or cross multiplying if you have 2 different ratios. So regardless of which way you do it, you should reach the same conclusion. So these are similar by side, angle, side. And our congruent statement is going to be triangle. We'll do AJK is similar to triangle. If we start with A, we're going to start with S, and then WY. All right, and the last picture that we're looking at for similarity is this triangle right here. There are 2 different triangles in it. I would really suggest drawing the triangles out separately. So we have that top triangle, AEF, and we know that AE is 8 and AF is 10. And then we have that whole triangle, ACB. We know that AC is 8 plus 4, which is 12, and AB is 10 plus 5, which is 15. So when you look at it at first glance, you might think, oh, well, you only have 2 sides. That's definitely not enough to prove congruence. However, you have angle A, which is in both triangles. So when you have a triangle that's like broken into 2 triangles, you have that reflexive angle. So if anything, it's side angle side, but we need to check the proportionality between the sides. So shortest side in AEF is 8, shortest side in ACB is 12. Longer side in the top triangle is 10, longer side in the bottom triangle is 15. So to check this, reduce them, change them to decimals, or cross multiply, whichever you prefer. I'm just going to reduce them. 8 divided by 4 is 3, 8 divided by 4 is not 3, it is 2. Let's do that again. And then 12 divided by 4 is 3. On the fraction on the right, 10 divided by 5 is 2, and 15 divided by 5 is 3. So these are proportional, so we know that these triangles are similar by side angle side, and our similarity would be triangle AEF is similar to triangle ACB. Remember that you can cross multiply and you would get 120 equals 120, or you can change them to fractions, which would be 0.6 repeating equals 0.6 repeating. Unless you set your proportion up differently. If you did 12 over 8 equals 15 over 10, your decimal is going to look a little bit different. But you should still reach the same conclusion. All right, in our last problems, we're going to be finding some missing sides, knowing that the triangles are similar. So here, find BE, which is X, and AD, which is Y plus 3. We know these triangles are similar. Even though it doesn't tell us, we know the triangles are similar because we know these lines are parallel. So we have corresponding angles that are congruent, and that makes these triangles similar by angle. So I would again suggest drawing little triangle and big triangle. So the little triangle is ABE. What we do know is BE is X, AB is 3, and AE is Y. In the big triangle, it's ACD. Oops, I just marked that wrong. CD. CD is 3.5, and AC is 5. AD is y plus 3. Make sure you add them and don't try to multiply them. So we can find x or y right now. It doesn't really matter. I'm going to go ahead and find x first. So I'm going to start with x. X, it corresponds to 3.5. And then I need to pick a second side in triangle ABE. I'm not going to use y because that's another variable and I don't want to have two different variables. So I'm going to use 3. And in the big triangle, 3 corresponds with 5. So my setup is x over 3.5 equals 3 over 5. I am going to cross multiply. So I'm going to do 5 times x, which is 5x. And then 3 times 3.5. Which is 10.5. And then I'm going to divide each side by 5. And so that's going to give me x equals, what is that, 2.1. So we found BE is the same thing as x, and that's 2.1. We also need to find AD, but in order to find AD, we need to find y. So now I'm going to set a proportion using y. So in my small triangle, y is on the bottom, and that corresponds with the y plus 3 in the bottom triangle. And then I can either use 3 and 5 like I did in the first one, or I can use 2.1 and 3.5, but I'd rather use non-decimals, so I'm going to use 3 over 5 again. And I'm going to cross multiply. 5 times y is 5y, and then 3 times y plus 3, I'm going to need to distribute. So when I do that, that's going to give me 3y plus 9. I'm going to kind of go over here. So I've got 5y equals 3y plus 9. I'm going to subtract 3y from both sides, which gives me 2y equals 9. I'm going to divide both sides by 2. So y equals 4.5. Sorry, I'm really cramming it in here. But we weren't asked to find y, we were asked to find AD. Well, now that I know y is 4.5 and y represents AE, AD is going to be 4.5 plus 3, so AD is going to be 7.5. All right, in my final one, we've got a word problem. It says when shadows are formed, similar triangles are created because of angle. It's because that the angle that the sun forms at a very specific time of day would be the same between every vertical object and the ground. We're going to determine the height of this roller coaster if Mary is 5 feet and 3 inches tall with a 3-foot shadow. The shadow of the roller coaster is 40 feet long. So we have two different triangles, right? We have the triangle formed by Mary and her shadow. So she's 5 foot 3 inches, which is 5.25 feet tall, and her shadow is 3 feet tall. And then we have the triangle formed by the roller coaster. We do not know the height of the roller coaster, but we do know that the shadow is 40 feet. So we're going to set a proportion up to figure out x. So we're looking for x, and it corresponds with 5.25. And then going back to the triangle with x, the bigger triangle, that's 40 over 3. So we're going to cross multiply. X times 3 is 3x. 5.25 times 40 is 210. We're going to divide both sides by 3. X is going to be 70, and this is the height of a roller coaster, so I'm going to put feet on that, so 70 feet.